Now in this video, we are going to take up one more problem on projections of lines. How to solve this problem, how to analyze this problem and solve it by manually. A straight line capital PQ inclined at 45 degrees to HP and 30 degrees to VP. The point P is in HP and the point Q is in VP. The length of the straight line is 65 mm. Draw the projections of the straight line. So he has given the true length and true inclination with respect to both HP and VP. But only the problem is one end of the point is in HP and the other end point is in VP. So whenever we have this type of problem, we have to solve the problem by taking from the top view always. So he says NP is in HP. NP is in HP. So then obviously NP is in HP, then NQ is on VP. You can see here. NP is in HP means what? When you look from the front view, that image will go to falls on the vertical plane. So this is P dash. Then you have capital P. Then NQ is on VP. So obviously your point will go to start from here. But if you consider from P dash, if you want to try to draw this, what happens? You know the true length, which is 65. So from here you draw a line inclined at 45 degrees to HP. So the length is 65. So we will go to get the locus of Q in the front view directly. No problem at all. But when you want to start from the locus of Q, but P should lie on this line. So we have to draw a projector from here to here. That is also fine. But you need to take the position of the point Q, that is Q1. We don't know where exactly that point Q1 will going to lie. Because if you take the second position as this, then what happens? You have to select a point in such a manner that the length is 65 and this angle should be 30 and this point where it cuts, it should also lie on the same line with that with respect to the P dash. So this is a little bit difficult and it is impossible. So that is the reason why we need to start from the top view. So that is the reason why I have given this as Q1, not as Q2. So I take any arbitrary point, and because he says the locus of Q is on VP, VP means what? It is on HP. So when you look from the top view, the image will go to fall on the horizontal plane. So I will go to start the problem from the top view. So Q1, I will take, so because this is the true length of the line, so I will take capital Q and this is the locus of Q in the top view. So from this point you measure an angle of 30 degrees and draw an inclined line and take the distance as 65 and cut it. So you got the point P. So you have capital P also. Now when you look from the front view, this P will going to be, because locus of P is on HP, so obviously that image will be on VP. So you got P dash directly. So then this will be capital P. So from P dash you measure an angle of 45 degrees because true inclination with respect to HP is seen in the vertical plane. So where you can see the image on the vertical plane, when you look from the front view, that image will go to fall on the vertical plane. So from P dash you measure an angle of 45 degree and draw an inclined line. Since the true length is same both in the front view and as well as in the top view, so you measure 65 mm, cut an arc on that 45 degree line. So you will get Q2 dash. So now you have the locus of Q in the front view. So this will going to be capital P and this will going to be capital Q. So this is how you will be able to write the initial position of the drawing in 3 dimensions. But how to do it on the sketchbook? First we are going to draw an XY line and you mark VP and HP. So since Q is on VP, so first it will be on HP. So obviously in HP you write this is the locus of Q. Consider any point on the XY line from mark that point as Q1. Then you measure an angle of 30 degree with respect to the horizontal by using the protractor and you draw an inclined line. Then by using the compass with Q1 as center, take the radius of 65 and cut an arc on this 30 degree line. So you mark this point as small p. And since it is the true length of the line, so you mark this as capital Q and you mark this as capital P. Then as P is on HP, so the image will go to fall on VP. So draw a vertical projector from P to the XY line and you mark that point as P dash and this as capital P. Then by using the protractor, you measure an angle of 45 degree with respect to the horizontal in the vertical plane because true inclination with respect to HP is seen in VP. So you measure an angle and draw an inclined line. Again, since the true length is same both in the front view and as well as in the top view, so with P dash as center, take the radius of 65, cut an arc on this 45-degree line. So you mark that point as Q2 dash. Since it is the true length, so you mark this as capital Q and you have got the locus of Q in the front view also. And then through Q2 dash you draw a horizontal dash dot line. So we have the locus of Q. Now, the next thing is you have to now since it is Q1, so I need to start from Q1. It's Q1 only. So now I want to find out the true length in the I want to find out the front view. I want to find out the front view. Since you need to find out the front view, from where exactly I need to start. So we have the true length in the top view. Okay. Since it is the true length in the top view, now if you want the true length in the front view, so if you want this line to be in the true length in the top view, that line should be parallel to XY in the front view. Where exactly? So if you look from the front view, P dash is already an XY line. But whereas Q1 is on VP, it will be on VP, so obviously it will be on HP. But Q1 dash, where exactly it will go to lie? Q1 dash will also lie on the same line as that of P dash. That means P dash is on HP, so Q1 dash is also on HP. Then only the line will going to be parallel to XY in the front view. If the front view line is parallel to XY, then only in the top view you will going to get the true length. So this line is the true length. Apply the concept there. Apply the same concept here. So P dash will be on XY line. Q1 dash is also on XY line. Then only the line is parallel to HP. Since the line is parallel to HP, so you are getting the true length in HP. So how to mark this? So Q1 is already on VP. Therefore, Q1 will going to be both on HP and VP in this particular position. So now you can see that here I will going to mark this as Q1 dash because P dash Q1 dash is parallel to XY line in the front view. Obviously in the top view, this line will going to be in true length. Now once you get this, now actually that Q1 dash is not on XY line because you have the locus of Q above HP by this distance. So with P dash as center, taking the radius of P dash Q1 dash, you rotate such that the Q will be cuts the locus of Q here. So this will going to be the point which will going to join between these two. So this will going to be the line which is in space. Q is on VP and P is on HP. So when you look from the front view, so this is the line which is making the angle of front view such that P dash Q dash will be the front view line. And now as we rotate this, what happens? In space, the image what you will going to get from the front view is also being get rotated because Q is already on VP. Therefore, in vertical plane, the arc will be traced on the vertical plane directly such that it will go to cut the locus of Q here. So you got Q dash. So when you look from the top view, when you look from the front view, that image will going to fall here, P dash, Q dash. So P dash is on HP and Q dash which will be on, so this will going to be on VP. So P is on HP and Q will be on VP. So this is how we will going to get the front view location of the line in one end is in HP and the other end is in VP. So how to do that in orthographic view? With P dash as center, taking the radius of P dash Q1 dash, you draw an arc by using the compass such that it will going to cut the locus of Q in the front view. So you mark this point as Q dash, then join P dash Q dash with a dark line. So this will going to be the front view line. Similarly, now I want to get the top view point. How to get the top view point? So to get the top view point, what I need to do is with P as center, taking the radius of PQ. Okay. Now I need to rotate this. Once I rotate this, what happens? Q is on VP now. So I want to take this line to be parallel to VP. How to get the parallel to VP? So here with P as center, taking the radius of PQ, rotate this such that both P and Q2 are in front of VP by same distance. So P is here, then Q2 will going to be here. So when you project from the top view, that line will going to be here only. Both P and Q2 is parallel to XY line. So now this is the line which is in space. As we are rotating the line in space, P is in front of VP by this distance. So Q2 is also in front of VP by the same distance. Therefore, PQ2 is parallel to XY line in the top view. As we look from the top view, the image will going to fall here, Q2. So both P and Q2 are in front of VP by same distance. Now it is parallel to VP. Therefore, you are getting the true length in VP here. So this is the line what we are talking about. When you are looking from the front view, the image will going to fall here. Okay. But actually, where is the point Q? Q is on VP. Since the Q is on VP, that is the locus of Q, Q2 will not be in front of VP by this distance, but whereas Q2 will be on the vertical plane. So as we are getting rotated here, this point is also being get rotated. So now with Q2 as center, P as center, taking the radius of Q2, you draw an arc such that it will going to cut the locus of Q in the top view. So you can see this is the line what we are talking about. When you are drawing between these two, both Q dash and Q will going to lie on the same line. So hence our problem is right. So this is how we will be able to analyze the drawing in 3 dimension. So here P is on HP, Q is on VP. So here in other words, P is on HP and Q is on VP. So how to do this when you are doing it in orthographic view? So here once you get this point, now I am going to take the true length in the front view. If you want to, this is the true length in the front view means what? Its corresponding top view should be parallel to XY. Where is the point P? P is in front of VP by this distance. Therefore, Q2 should also be in front of VP by the same distance. So draw a horizontal projector from P and from Q2 dash to draw a vertical projector such that the Q2 will going to cut the horizontal projector drawn from P. Therefore, PQ2 is parallel to XY in the top view, hence it is the true length in the front view. But actually Q2 is not in front of VP by this distance, but Q is on VP as according to the given problem. So with P as center, taking the radius of PQ2, you draw an arc such that it will going to cut the on the XY line because in the top view, because the locus of Q is on XY line in the top view, that is Q is on VP. So once you cut the XY line, that will going to be the locus of Q according to the given problem. So mark this point as Q, join between P and Q with a dark line. So when you join between these two, both will going to lie on the same line. Therefore, your problem is right. So how to analyze finally? This is the final conclusion. What I can do is, this is the front view because the top view line is inclined. You know this is the top view because its front view is inclined. You know this is the true length in the front view because its top view is parallel to XY. You know the true length in the top view because its front view, that is P dash to 1 dash, is parallel to XY. So hence our problem is right. So this is how you will be able to analyze it in 3D, and also you can solve it by using the manual sketch. Thank you.